Hi, welcome to Genesis Engineers Academy. In this video, I am going to discuss on shafts. So, a shaft is a rotating member, usually of circular cross section, which transmits power from one place to other place and also provides rotational motion. So, if you observe this one, you will come to know. So, it is an electrical motor and it is a pump which runs on a single shaft. That's why it is called as a monoblock. So, this is the shaft and this electrical motor rotates this shaft. The same shaft rotates the impeller in the pump. So, that is why a shaft is basically a rotating member. Next, machine elements such as gears, pulleys, flywheels, clutches, sprockets are mounted on the shaft and are used to transmit power from the driving like a motor or engine through the machine and to the consuming place, that is pump, that is compressor, all these things which requires that is rotational power. So the shaft generally rotates in bearings, maybe rolling bearings and otherwise bush bearings like journals. So the shafts are usually cylindrical and it may be solid or what you call hollow. An axle is so this axle is similar to shaft only, but the ends are circular and the other cross section may be circular, that is square, all these things. But is in generally, what is the difference between a shaft and axle? So it's a part of an axle. Axle is a part of a shaft and it is usually stationary. It is a truss and it enables others to rotate over it. That is, it is used that is at the end of that is axle is like this one. So in this the tire of a vehicle rotates. That is why it is also considered to be a shaft, but it is called as an axle. Axle is basically, so this is axle, this is basically stationary and it rotates. And it is subjected to bending moment only. So it is not subjected to torsion as it is stationary. And these axles are used in car wheels, rope sheaves and hoisting drum. Next one is spindle. So when you call this spindle, it is a short shaft. You can say it is a short shaft and imparts motion either to a cutting tool or chuck, all these things, drill, press spindles. Okay, so these are all classifications. Next one is types of shafts. So these are the types of shafts. So this may be the transmission shaft, input shaft and output shaft. These are used in gearboxes of vehicles. The other one is crankshaft. So this is also used in IC engine, that is to move the piston through connecting rod. And this is a counter shaft. This is also used in gearboxes. So this is an intermediate shaft. Okay, so these are the another things, line shafts, and the other thing is machine shaft, Okay, so this is a spindle shaft, whatever it is. So based on the application, these are divided. Basically, they are rotating. Now, transmission shafts. So transmission means transmission of power, that is torque, and rotation, that is angular velocity. These shafts transmit power between source and the machines absorbing the power. Sources means maybe engine, IC engine, or electrical motor. And the absorbing are so many. As an example, I can tell you, that is pump. Next one, these are the transmission shafts. So in that there are counter shafts, line shafts, overhead shafts. So these are all used in factories and vehicles. So since these shafts carry machines or machine parts such as pulleys, gears, therefore they subjected to bending and also twisting. Twisting is compulsory. So in this also we may come across bending sometimes. So you have to keep in mind. So this is for bending moment, this is for twisting moment. Machine shafts. These shafts are form an integral part of the machine, like crank. Crank is a shaft, but it is an integral part of that is IC engine. Okay, so such shafts are called as machine shafts. So this is an example. You can place it anywhere, and this is the crankshaft. Next, you can also see this one. So this is the arrangement of the gears through shafts in gearbox that is used for transmission of power. Okay, so this is we call it as input shaft, and this is output shaft, and this part are two combinations that are counter shafts. Okay, so these are counter shafts. From the input shaft will get the power or reduced or increased of the power, that is the speed, and goes to the output shaft. That is why it is called counter. It rotates in counter to the main shaft. You can say this is the main shaft. Okay. A counter shaft is a shaft that runs parallel to the main shaft. So this is the counter shaft and this is the main shaft. This runs in parallel in gearbox and also carries the pinion wheels, means gears. So this is the counter shaft of this one. Next, standard sizes. So for transmitting shafts, we use 25 to 60 5 mm that is steps. That means initial shaft size is 25, 30, 35, 40, 45. You have to keep in mind while calculating shaft diameter. If you get shaft diameter as the 23.5, don't go for 24, to go for 25. Okay, so suppose 28.5, don't go for 29, go for 30, because these are the available shafts. Up to 60, it is 5 mm steps increment. From 60 onwards up to 120, 10 mm. That means 60, 70, 80, 90, like that. And after 110, so you have to remember 25, 60, 110, then 140, then 500. Okay, so 500. So here the step is 5, here the step is 10, here the step is 15, here the step is 20. From I think you understand well. Now, standard lengths 5 meters, 6 meters, 7 meters. If we require for line shaft like other things, if you wanted to have more than 7, so you have to use the shaft couplings. Okay, Next one is materials. So the general material used for mild steel is that is shafts is mild steel. When you want to have higher strength, alloy steels like nickel chromium or chromium vanadium steels are also used. Shafts are generally formed by hot rolling process and finished to size by cold drying or turning and grinding. Sometimes you can also use some finishing operations after hot rolling, because shafts finish is very smooth. So you have to carry out the other finishing operations to make the shafts fit for the other applications. Now the stresses generally induced in the shafts when it is put in operation. The shear stresses are induced due to transmission of the torque. That means we are applying the torsional load. Okay, so due to this we have the torsional shear. As you know there are two shear stresses. One is direct shear, the other one is torsional shear. Next, the bending stresses, because of bending stresses may be induced because of the other parts we use like pulley, gear and other things. Because of this, the shafts may be subjected to bending moment. Due to that, bending stresses are created. So the machine likes gears, pulleys as well as weight of the shaft also. There is a scope for bending stresses. The other thing is sometimes you have to combine both these. So this is bending stress, that is normal, and the other one is called shear, that is torsional shear. So sometimes it may be useful to combine these two things. Now designing of shafts. So the shafts may be designed based on strength and also rigidity or stiffness, what we generally call stiffness. So torsion equation, T by J is equal to tau by R, that is equal to G theta by L. So if you combine these two terms, we call it as strength basis. If you combine these two, that is tau by R, G theta by L. Okay, not this. So this is this one. T by J is equal to G theta by L. This is stiffness basis and this is strength basis, that is T by J is equal to tau by R. So don't use this combination. Next, in designing shafts on the basis of strength, shafts subjected to twisting moment or torque, shafts subjected to bending moment only, shafts subjected to combined twisting and bending moment. So I am not going to use this part, that is axial load, but there are 4 chances. One is we consider only twisting moment in this case, we consider only bending moment in this case, we consider both the cases in designing the shaft based on the strength. Now we will concentrate on when shaft is subjected to twisting moment only. So that is when the shaft is subjected to torque only, the diameter of the shaft may be obtained by using the torsion equation, that is this one. So where T is the twisting moment or torque, so its unit is Newton meter, its unit is meter to the power of 4, its unit is Newton per meter square, its unit is meter, This is Newton per meter square, that is rigidity. This is angle of twist. Okay, so it must be in radians. Okay, so pi radians is equal to 180 degrees that you have to take. Okay, so based on if it is angular twist is 1 degree, so how much this? For 180 it is pi. For 1 degree, so it comes about to pi by 180. You have to convert. Okay, next this tau is torsional shear stress, theta is angle of twist, r is the distance from the neutral axis to the outermost fiber, that is neutral axis is usually longitudinal axis. This is r if it is shaft. Okay, so this is used where L is the length of the shaft, G is the modulus of rigidity. For round solid shaft, polar moment of inertia for a circular cross section is this one. So this is polar moment of inertia and this is the centroidal distance, that is d by 2. If you divide j by y or otherwise it is r, okay, so you will get pi by 16 d cube. This is polar section modulus. Polar section modulus is this. So if you multiply this polar modulus with the tau, you will get torque transmitted or to be transmitted by the shaft. Okay, so very good, very important formula. Okay, so torque is equal to tau into polar section modulus. This is polar moment of inertia for circular. So if you know the torque, you can get the power transmitted, that is 2 pi n by t, 2 pi n t by 60, where n is speed of this one in rpm. So you will get watts, and here the torque is mean torque. Okay, so that is very important. Okay, next one is strain energy is this of tau square by gj. Okay, all these things. So this is the strain energy. Strain energy per unit volume, that we call it as tau square by 2g. Okay, so you will remove all the things, that is L by G. So this is the equation to be used when solving the problems for a solid shaft. Next one is hollow circular shaft. Hollow means you will have two circles. Okay, one is small d, that is the other one is capital D. So this is capital D and this is small d, and this material here. Okay, so here the polar moment of inertia is pi d to the power of 4 minus d to the power of 4. So you have to subtract moment of inertia, that is pi d to the power of 4 by 64 minus pi d to the power of 4, small d by 32. It is 32. Okay, wrong, it is 32. So it is 32. It is 32. You are going to get pi by 32 d to the power of 4 minus d to the power of 4. Section measure. So this is general moment of inertia. It is not polar moment of inertia. Polar moment of inertia means suppose it is a shaft. Okay, so this is z axis and this is y axis and this is x axis, suppose. So this moment of inertia x or y is taken as pi by 64 d to the power of 4. Okay, for z we apply perpendicular axis theorem, that is Iz, that is called j, is equal to pi by 64 d to the power of 4 plus pi by 64 d to the power of 4, you will get pi d to the power of by 32. That is polar moment of inertia. 2 times of moment of inertia. Okay, so this is okay. Okay, next one is the same formulas can be used for getting the torque. Torque is equal to Zp into tau. In that case, you have to use pi by 16 d to the power of 4 d to the power of 4 by d into tau. And per power transmission, you can use P is equal to 2 pi nt by 60. Okay, so these are familiarly used. When shafts are subjected to twisting moment and bending moment, that means there are shear stress and also bending stresses. So various theories are developed based on this one. If we wanted to combine both these stresses, that is sigma b and tau. So the first theory is maximum shear stress theory or Guest theory. So it is basically used in mild steel. Maximum shear stress theory is equal to, if the maximum shear stress is equal to or greater than, that is shear with taking factor of safety. Okay, so this is maximum shear stress theory, also called as Guest theory. According to this theory, this theory is used in for mild steel, also called as ductile material. And the other is maximum principal stress theory, or otherwise maximum normal stress theory, or otherwise Rankine's theory. So this is basically used in brittle like materials. Like the shaft is made with cast iron, you have to apply this Rankine's theory, not this theory. So based on the material only, you have to apply this. So according to maximum stress theory, what is maximum shear stress? So for a general thing, I can say that is principal stresses 1, 2 is equal to sigma x plus sigma y by 2 plus or minus sigma x minus sigma y by 2 whole square plus tau xy whole square. So this is the basic equation for finding the principal stresses, that is minimum principal stress and maximum. This is maximum, this is minimum, this is the normal notation we usually follow. So according to that, the square root part we'll call it as maximum shear stress. Okay, so if you combine, that is we know that bending equation m by I is equal to sigma b by y. Okay, sigma b is equal to, what is that, my by I, or otherwise m by z. So this is the equation we are going to substitute in place of sigma b, where z is equal to, what do you call, z is equal to pi by 64 d to the power of 4 by d by 2. So you will get pi by 32 d cube. So this is section modulus, and whereas Zp is polar section modulus, in that case we use I. So if you substitute all these things, you will get this 16 by pi d cube, where d is the diameter of the shaft. This is the bending moment in Newton meter. This is the twisting moment also in Newton meter. So you will get maximum shear stress, and equivalent twisting moment is the multiple factor of this one. So that we call it as equivalent twisting moment. So we have to use this one. Okay, for maximum shear stress theory or Guest theory. Okay, so this is equal twisting moment. Next, according to maximum normal stress theory, so this is normal stress theory. Just now we have only one for stress, that is why we use this sigma by 2. Okay, you understood this one, sigma x plus sigma y by 2. If you have this one, you will have sigma x by 2. The same thing, sigma x by 2 whole square. This is tau square. So if you substitute this equation for bending stress and also shear stress, you will get this one. Okay, so this is bending moment. This is equal twisting moment. Okay, so you can also write sometime. No need to this m plus equal twisting moment. So equal twisting moment, the equal bending moment is the average of these two. Okay, you can say that way. Okay, so this is equivalent bending moment. So sometimes you may forget to put this off before this. Okay, so remember this one. So this is for normal stress theory. Next one, design of shafts on the basis of rigidity. So I already told you. So tau by theta. Okay, so this you can say T by theta also twist, that is torque for unit twisting. Okay, so this I can say torsional stiffness. Okay, T by theta is torsional stiffness. That is equal to Gj by L, where L is the length of the shaft. Okay, next Gj is called as torsional rigidity. Gj by L for unit length, it is called torsional stiffness. L by reversal of stiffness is called flexibility. That's all for today. If not subscribed, please subscribe and also press the bell button to receive all notifications. Don't forget to press the like button if you liked this one. Share among your friends and also comment